to be confused as far as when do I expand or when do I condense. It's smushed, so you're going to know to like write it out. There's no fractions, there's no addition symbols, right? There's no coefficients, so you're going to know to expand it. Okay, first things first, we went over yesterday. Remember, if you guys recall your roots, if this is really, let me put an x in there, x to the 1/2, right? If I give you, say, 2, this is really 2 to the 1/3, right? Whatever that root is, that's your denominator, right? We went over, bless you, we went over that. If you have, say, to the 4th, x to the 3rd, this is x to the 3/4. I have 3 x's, that's my numerator. It's to the 4th root, that's your denominator. Yeah? Okay, we need that here. See how you have a root to the 4th? A 4th root? Okay, so the equivalent is, oh wait, let's do a bracket then. Is 1/4, right? Because that 1/4 is there, correct? Okay, well, we'll kind of solve this 2 ways. At some point, I'll split afterwards and I'll solve it another way, because if you guys are taking a state test and it's multiple choice, I'll show you the other way it can be written. So let's go this way first. Okay, power rule says that I can take that exponent and bring it to the front as a coefficient. I could bring that forth like right here, right? See that n is an exponent and now it is a coefficient to the log, right? Okay, that's your power rule. So now I'm going to rewrite and I get, bless you. And let me know if I copy something wrong. All right, guys, I'm recording. Okay, so we get that. Okay, so now we're going to move forward. I want to split my bases. So I want to utilize the product property, which is when you're multiplying multiple bases, it's an addition, correct? See, mn, multiplication. Here are those 2 bases. So I'm going to split these 2 and put an addition symbol. Ladies. Okay, so 1/4. Now I'm going to put a big bracket to break this up. And then log x plus 1 cubed plus log x minus 2 squared. And so that 1/4 is going to stay in the front, because it was all under that 4th root. That's why I have the bracket. Afterwards, I'll distribute it the other way. And you just have to give me whichever way you prefer. They're both correct. Okay, what should be my next step?
Raising x plus 1 to the 3rd and then x minus 2 to the 2nd.
No, well, where should I put it? What should I attack and where should I rewrite it? Go back to your power rule. So see the 3 and the 2? Where should I put the 3 and the 2? The x, go ahead, sorry. I didn't mean to, oh my God. Yeah, in front. Oh, I hit the camera. I was like, please don't shut it down. Okay, that's going to move to the front here, and the squared will move as a coefficient here, correct? And then we are complete. So 3 log x plus 1 plus 2 log x minus 2, and this is, you're done. Okay, why don't we split these 2? This is our solution. Now, you don't see the base here, but you guys know whenever you don't see it, just like we know this is square root, right? If I give you this, you guys know it's 3, right? Plus or minus 3. If you don't see the base, it's always log base 10. You don't have to write that. I'm just letting you guys know. It's always log base 10, and that's why in your calculator, this is always log base 10, and this is where we change the log. Oh, it's not even on. Oh, it doesn't want to work. Oh, I think it died. Oh, there we go. Yeah. Okay, so that's, all right, what's the other way of solving this? So let me come back. Let me rewrite this step. No, I won't. I'll just start from the beginning. And then I'll shut this off. Okay, here's the other way that's still correct. Meaning you don't want the 1/4. And at the end, I'll show you how we'll get them to match. All right, so here's the original one. What some people will say is, okay, we're going to rewrite it. And you might actually prefer this, so just look at it. You might actually like it. Okay, the 1/4 is the root, right? Because it's a 4th root. And what some people would want to do is they would want to take that distributive property and distribute that to x plus 1. This is 3/4. Because remember, this 4 is here, and now we're putting it and maybe you don't like all the grouping symbols with the brackets, and maybe the brackets kind of confuse you. So you're like, wait, if this is a x plus 1 to the 3rd, and that's a base, then I have 3 of them, and I'm in a 4th root. Here I have 2, x minus 2, there's my 2, but I'm in a 4th root. And you can create your fractions from there, and then you don't have the bracket and the big grouping symbol. And now, what are you going to do? The power rule says to go ahead and now, well, we're going to separate the two bases. So we'll separate the bases here, the product. So log x plus 1, 3/4 plus log x minus 2, 2/4. And if you want to reduce to 1/2, you can. Nothing's wrong with that. And now you'll go ahead and take care of the power rule and bring that to the front, and now you are done. So 2/4. It's honestly a 50-50 with students. I have students that like creating the 3/4 and 2/4 and then separating it and having separate coefficients, and then I'll have students that like bringing that 1/4 bracket and just having non-fractions. So I think it's just your comfortability with the fractions, but they're both equal. And if you wanted to prove it, right, so this is your end result. This is expanded, it's beautiful. Here, how could I make that look like here? If you were to just distribute that, this is 3/4 log x plus 1. Notice it matches it. And then multiply here, distribute it, plus 2/4 log x minus 2. And so you can see they match up. And so it's just a difference of preference. This can be given on a multiple choice like SAT, PSAT, or this. They're both the same. They're both correct. And you would get both equal credit for that.